Hi, everybody, and welcome to another session of the Infrastructure as Code podcast. I'm your host for today, Ohad Maislish. You can follow me at DevOps Ohad. You can go and watch more sessions of the Infrastructure as Code podcast at the IaC Podcast at Twitter or the iacpodcast.com, the website. Today, we have an amazing guest. We have Amir Jerbi, CTO and co-founder of Aqua Security. Hi, Amir.
Hello, Ohad. Hi.
Hi, great seeing you. Thank you for coming today. You have a lot to share. You and your co-founder built an amazing company. Tell us a little bit about yourself and about Aqua Security.
Sure. So, hi, everyone. Amir Jerbi. I'm the CTO and co-founder of Aqua. Started Aqua October 2015, right? So about 7 years ago. We started mainly doing container security. Back then, containers just started with Docker, and companies were looking for ways to adapt them. And security was one of the big things. How do you secure containers? And then, after a while, we added more and more capabilities. We added Kubernetes, we added cloud, we added scanning, and I'm sure, Road, that we're going to talk about that as well.
Amazing. Just for you who are not aware of Aqua Security, you obviously do a lot in security, cloud native security, more developer focused security. You're doing very well. You're 600 employees, maybe more now?
Yes, about 600 employees. I'm based in Tel Aviv, Israel. So here for me, it's already night. And the company has a headquarters also in Boston and offices in Israel and India.
Amazing journey from scratch to 600 and growing fast. And obviously a lot of cloud DevOps engineers need solutions for security, and Aqua Security is definitely the best or one of the best options to explore. So yeah, you started with Docker, you moved to Kubernetes, but today we try to focus more about Terraform, CloudFormation, infrastructure as code. Amazing that you're doing that as well. Can you maybe let's start with your main open source, Trivy. For those of you who still didn't check Trivy, you must go and check it out. It already has like 1,600 or 17,000, 60,000, excuse me, or 17,000 GitHub stars. So a lot of people use it and like it. Tell us about your amazing open source Trivy, Amir.
So Trivy started about 3 years ago, maybe 3.5 years ago. It started as a vulnerability scanner, right? Open source vulnerability scanner, focused on container images. So, back then, think about Aqua. We are providing security for cloud native and containers. And in the domain of cloud native and containers, there are two major parts for doing security. There is security that you do as you are building the container images. Sometimes it's called shift left, where you are trying to find vulnerabilities, misconfigurations, malware, right, as part of the build system. And there is the security that you are doing for the runtime. As you are running the containers, you are trying to identify malicious activities and, of course, stop them from happening. So Trivy fitted fantastic into the shift left paradigm. So developers, writing their own Docker files, building container images. And as they are doing that, before shipping the container image to production, they were looking for tools that will help them evaluate the security of that container image. And Trivy, the way it works, you basically integrate Trivy into the CI/CD, Jenkins, GitHub Actions, Bitbucket pipelines, whatever. And as you are building your container image, basically you are running a Trivy step. What Trivy does, it will open up your container image. It will look for all of the operating system packages, all of the programming languages, and then compare them against a database of known vulnerabilities. Right. So, for example, if you have a Node.js of a specific version, and this Node.js is known to be vulnerable, Trivy will tell you, hey, you're using this version of Node.js, it's vulnerable, please update it to the latest and greatest.
And it happens very often that you have tons of vulnerabilities. And you said about active scanning as well. So let's say I'm using the right Node.js versions and I'm using the right Docker-based images, and then I deploy that code, deploy those Docker images to my Kubernetes cluster in EKS, for example. Do you help customers prevent security runtime errors as well?
Yes, absolutely. Because, at the end of the day, we see a lot of cases where you don't have vulnerabilities, but still customers are getting attacked, right? Whether it's a 0-day, whether it's a misconfiguration. So at the end of the day, you need to shift left in order to reduce the attack surface and to reduce those security issues, but you also need something at your runtime that will monitor and prevent attacks. For that, actually, we have another open source project. It's called Tracee, Tracee, Tracee. What Tracee does, it monitors all of the runtime activity. It monitors containers and even regular Linux VMs. And if it identifies malicious activities, it will notify you. It will give you an event, whether it's a webhook, a Slack message, Teams, all of that. So together with Trivy, they pretty much complete each other. Trivy shifting left, identifying misconfigurations, vulnerabilities, secrets before you move to production, and Tracee monitors your runtime environment and detect attacks.
It's interesting. I think I've heard the analogy to security in casinos, meaning you have the bodyguards in the entrance that make sure you don't have any weapon and you don't do anything extremely out of the ordinary. But even once you enter the casino, you have tons of cameras and you have a lot of security folks running around and making sure that everything is okay. So you need to have both. A, making sure that nobody is trying to attack immediately when the image is created, let's say, and B, even if the Docker image seems to be okay, but you do something wrong with that, maybe even an honest misconfiguration that is very dangerous, you need somebody from the inside to make sure that nothing bad is happening.
Yeah, because one of the challenges is that about the things that we don't know. So think about the situation, it's a Monday morning, you scan your images, everything is fine, you don't have any vulnerabilities, you deploy them in production. But, now they are running in production, and after a week, a new vulnerability is discovered, right? So the next Monday, suddenly you might have hundreds and thousands of images running in production. Now they are vulnerable. They were not vulnerable a week ago because nobody knew about this vulnerability. And now you need to act very fast, right? You need to find where are those vulnerabilities running in your production. You need to patch them. You need to update the versions. And it takes time. Sometimes it can take days, maybe weeks. For that, this is where runtime protection is extremely useful for those cases that, you need something to protect your production assets.
It's amazing how many risks you have in order to properly run production environments. Awesome. So you help in Docker containers and you help in Kubernetes. But let's talk more about Terraform and infrastructure as code. Besides of Trivy, you also have an open source that you acquired, which is the engine of your Terraform scanning, tfsec, Terraform Security tfsec. Tell us more about tfsec and how it's integrated into Trivy.
Yeah, absolutely. So I mentioned, Trivy started about 3.5 years ago as a vulnerability scanner for container images, right? But then what we've seen that we have a huge community. They are leveraging Trivy. They're integrating Trivy as part of the CI, right? So every time you build a container image, you scan it with Trivy, you find vulnerabilities. But then we were getting requests from the community, can you do more? Why? Because in cloud native environments, people are not just building container images. They're also building the infrastructure of their cloud. They're using CloudFormation, they're using Terraform, and other infrastructure as code mechanisms. in order to describe the cloud infrastructure and later on to deploy right into the cloud. So there was a big ask in the industry about how can you also check for additional security aspects? How can you check for the configuration of those cloud resources that the Terraform and the CloudFormations are generating? And that's what we did. So we took Trivy. We said to our community, you're already using it. It's in the pipeline. Let's add more security checks. Let's add configuration checks. And now the next step was to add into Trivy those infrastructure as code engines. So Trivy today can scan for Terraform, ARM templates, CloudFormation, Kubernetes YAML files, Docker files, right? And there are a lot of configuration items. And basically the way it does that, it uses different engines. So for Terraform, we use tfsec. tfsec is also owned by Aqua Security. It's an open source project that can scan Terraform for misconfigurations. We have another project for CloudFormation. We have another project for Kubernetes, right? So Aqua maintains all of those security configuration checks, and the benefit to the user is that now you have one step in the CI. This step can check for both vulnerabilities, secrets embedded in your code, and also...
This never happens. Nobody enters secrets into the code. Nobody. It never happens.
Yeah, but we see that a lot, because when you now run a single scan, suddenly you get dozens and sometimes hundreds of those vulnerabilities, misconfiguration, secrets. And the next step is, how do I prioritize? How do I make sure, where do I focus? What do I need to fix?
Yeah, I hear that often, that you get tons of alerts, but this is not necessarily actionable. What can make it into actionable information is to prioritize and to help you focus your limited resources. Awesome. So you mentioned tfsec and Terraform, you mentioned CloudFormation and ARM. Just making sure that our audience is fully aware of those frameworks. CloudFormation is infrastructure as code for AWS only. ARM template is the Azure Resource Manager for Azure only. So basically you provide support for security scanning for infrastructure as code in a multi-framework situation. So you have many users. And let's maybe talk about an example of something that tfsec or others can capture and alert. Let's say I am writing some Terraform code and I'm about to provision a new EC2 instance with Terraform, but I want to test it quickly, so I want to keep SSH open, maybe even to too many incoming IPs. This is probably not something very secure to do. What will tfsec and Trivy will do in when will I get alerts? When I do something weird like that in other situations? Tell us more about the value and the actual alerts that something like tfsec and Trivy issue.
So first of all, Trivy comes with hundreds of those security configuration checks. They are based on security best practices. They are based on compliance and regulation frameworks like the CIS. And what we did, we've implemented code. It's based on Rego, by the way. Rego is another. Rego, yeah. Mm-hmm. It's a language that allows us to evaluate, syntax and JSON or different formats. So what we did, we took those compliance and regulations like the CIS benchmarks, and we've implemented Rego checks, right, to check each and every one of those best practices and requirements. It's all open source. By the way, you can go to avd.aquasec.com. It's a website that has all of the security checks that are open source and are in the product. Now, to your question, there can be two use cases. One is you just did a violation to a security best practice. Maybe you opened your EC2 instance to non-standard port, right? And maybe this is a known security best practices, meaning we will have a security test for it. And when you will run trivy, we will take the CloudFormation or Terraform, we will check it against all of the security best practices, and we will tell you, hey, you have a violation. This is one option. The second option is that we don't have a check for what you just did. Maybe it's not a security violation. Maybe it's not something that is documented as bad practice. In that case, what we allow the users, we allow them to write their own Rego scripts, Rego checks. You can put the Rego check and tell Trivy to use those custom checks on top of the built-in checks that we come out of the box. And in this case, we will use the user's check and tell, and as we are scanning this repository, not only the out-of-the-box checks, but we will use the custom checks as well.
Awesome, which obviously reminds me of OPA, Open Policy Agent, both for writing your own policies as code, and that code is Rego, like Open Policy Agent. And honestly, we see more and more developers using policy as code, writing their own policies, whether it's in Open Policy Agent or another framework like in IaC, because eventually you have your own best practices or procedures and processes as a customer on how to do things, and you want to customize those security scanning according to your processes. And this is very, very powerful and saves a lot of time or mistakes, expensive mistakes later on. So I personally encourage our audience to look at the policy as code mechanisms such as Open Policy Agent, such as Trivy, to write your own rules and not just the default rules that come out of the box. Awesome. Amir, what is next for Aqua Security? Where will you be in a couple of years?
So, Aqua Security, we are fans of open source, and I mentioned, two of our popular, Trivy and Tracy. Of course, we have a commercial offering on top of them. So we, for the commercial, we provide an equivalent dev security where we have guardrails in the development pipeline to do those checks and find vulnerabilities. So we have a commercial product on top of Trivy. And the same we have for the runtime with a commercial product that can find and stop attacks, right? So just to mention it, I can tell you that in the open source, we got a lot of requirements to complete the infrastructure as code checks with actual cloud checks, because you can leverage the same CIS benchmark, the same Rego checks, not only on your infrastructure as code, but also to connect to your AWS, Azure, Google Cloud account and run the same checks and tell the users whether they have misconfigurations, that exist today, right now, in their own cloud. So we just launched a few months ago Trivy AWS. So you can use your AWS access key and token. You can connect Trivy to your AWS account, and you can run exactly the same checks that we have for the infrastructure as code on your actual AWS account. Azure and GCP are coming, and the purpose is to allow the community basically to have a set of security rules that they can run both on the infrastructure as code, but also on their production cloud accounts.
It's amazing to see how you attack this domain end-to-end, from shift left to some other very popular areas like the cloud resources themselves in AWS, not to mention drifts that happen very often, and some engineer with some direct access to the cloud changes something without changing the code. In an ideal world, everything is happening through code, but in the real world, some things are happening directly on the cloud accounts. And it's amazing to see how IaC is basically providing a full stack security solution focused on developers, focused on on cloud native approach. This is amazing. Amir, again, it's been a pleasure having you today as our guest. What you have accomplished in Aqua security and your upcoming plans going forward is truly amazing. Also, your contribution to infrastructure as code domain, whether it's Terraform with tfsec or CloudFormation and ARM templates, and I believe you will provide more and more support as the market needs. So again, thank you for contributing to open source. Thank you for building an amazing company that helps security in so many places. And thank you for being our guest. It was very interesting listening to your story. Thank you very much. Thank you for our audience for joining today. Again, I'm Ohad Maislish. You can follow me at DevOps Ohad. And please also share with your friends about the IaC podcast if you want to listen more about infrastructure as code. Thank you and bye-bye.